in this car, we have two cars headed in the same direction. The trailing car is going faster than the car in front. And after they collide, they're going to bump into it because they're going to catch up with it. And the guy's not paying attention. He's on his cell phone or something, bumps into the guy in front of him. We know the velocity of the trailing car after the collision. We've got to figure out the velocity of the lead car after the collision. And we also want to determine if the collision is elastic. And to do that, what we're going to do is going to calculate the change in kinetic energy and enter into, in this problem, the change of Ke prime minus Ke. So let's start with momentum. All right, so the momentum before the collision is m1 v1 plus m2 v2. Not a problem there. The momentum after the collision is m1 v1 prime plus m2 v2 prime. And the only thing we don't know here is v2 prime. So I'm going to solve for v2 prime. I'm just going to go m2 v2 prime is this bit. Oh, that was wrong. m1 v2, copy that, paste it in, minus m1 v1 prime. So now we have almost solved for v2 prime. We just have to divide both sides by m2. So I'm going to just copy. Hopefully I'll successfully copy and paste this time. Paste, close, divided by m2. Now we have a formula for v2 prime. Excellent. But what's the question we're trying to answer? Is this an elastic collision or not? Right? And to do that, we have to calculate the kinetic energies. So Ke, the kinetic energy before the collision, is 1/2 m1 v1 squared plus 1/2 m2 v2 squared. And the kinetic energy after the fact is 1/2 m1 v1 prime squared plus 1/2 m2 v2 prime squared. And then delta Ke is just Ke after minus Ke before. Well, let's start putting all of this together. What are our variables that we know? m1, v1, m2, v2, and v1 prime. Let's stick those in. They are 1447 kilos, 14.8 meters per second, 1355 kilos, 13.3 meters per second, and then 13.6 meters per second. V2 prime is, I'm going to use parentheses because I've got a numerator with more than one term. So m1 times v1 plus m2 times v2 minus m1 times v1 prime divided by m2. So we now know v2 prime is 14.58 meters per second. So it's going a little faster than it was before. And we have to calculate the different kinetic energies. Well, let's do them one at a time. 0.5, 1/2 times m1 times v1 squared plus 0.5 times m2 times v2 squared. So that's kinetic energy beforehand. Kinetic energy afterwards, Ke prime. All right, we have 1/2 times m1 times v1 prime squared plus 1/2 times m2 times v2 prime squared. and that's our kinetic energy after the fact. And so our delta KE, KE is going to be KE prime minus KE. And so we've got a loss of kinetic energy in the problem. A loss of kinetic energy in the problem means that this collision is inelastic. And what Canvas is looking for is this number right here, minus 450 joules. And that's it for this problem.